Okay, so this is 9.1 side triangle congruence using transformations. So the idea behind here is that you have two triangles and you can show that they are the same according to all three sides being the same length. The angles have to be the same length after that. So you don't have to show all the angles, you only have to show the sides. So AB, they say coincides with KL. BC would coincide with LM, and CA would coincide with MK. That's basically what you're doing. If you wanted to get from the blue one to the pink one, you could say that this is reflected over across the y-axis and they coincide, and then it was rotated, and so they still coincide. So you could say that triangle ABC maps onto triangle KLM. And the order of those letters matter. So let me just show you on this first one here. So we had triangle ABC, and it shows that it maps onto DEF. So DEF. So A, B, C, D, E, F. So how could it go from A, B, C to D, E, F? And I would say that would be a reflection. Okay, and then the next one. You can see that these are a little bit different because notice it goes A, B, C goes with D, E, F because there's one tick mark on this one, 2, 3. So it goes 1, 2, 3, kind of going around counterclockwise since we're going around this one, but clockwise as you're going around this one. So they do coincide because all the sides line up. So A would coincide with D, because the respective sides that form it coincide, like all the sides that coincide. So because the 1 tick mark and the 3 tick mark form it. 1 tick mark, 3 tick mark. All right, so that is 9.1, very fast. And then we can do 9.2, because you might as well have fast videos that go do a lot. 9.2, using it in proofs, because they're very much related. And so we have a postulate. So basically, these are things that you're going to have to remember. Reflexive property means that like it's the same as itself. Like triangle ABC is the same, is congruent to itself. Usually we say this with an angle is congruent to itself or a side is congruent to itself. Usually like two triangles might share a same side. And so we say that side is congruent to itself because then it kind of like it separates the statement for both triangles. Then there's the symmetric property of congruence. Basically, if one of the things is congruent, like if AB is congruent to CD and CD is congruent to AB, like you're just basically like 1 plus 3 is equal to 3 plus 1. That's kind of what you're doing. Then there's the transitive property. I call this like take out the middle guy. So if A is congruent to B and B is congruent to C, then A is congruent to C. So that middle guy B gets to go, comes out. So those are things you'll need to know. Remember that bisecting means splits in half. We have a segment bisector. That half point is the midpoint. If it's perpendicular at that point, it's a perpendicular bisector. Yeah, just coming down here. So we are going to, I want to just show you an extra one because I think proofs can be super tricky. So you'll always have, with a proof, you'll have the given statement, and then you want to prove this. So I'm just going to look here. We have these two triangles. I have this side is the same as that side. And I could say that AB is the same as itself by the reflexive property. So the only other thing I would have to prove is that this side is congruent to that side. And I don't know if it is. But so let's see. We would have BC and BD. Good. So here's this one. So ACDC is given. That thing's given. And then given BC is congruent to BD. So let's see. When it says it's a segment bisector, that means that those things are the same. So that would be definition of segment bisector. And then Then we have all this stuff. We're working on it. Now we say that AB is congruent to itself. So that's where like you're looking at itself. And so you're using it for two parts to it. That's reflexive property. And then we got that. All right, so let's try this. Use these triangles to answer the question. So A, B, C, D, E, F. Which answers need to be true to show side, side, side? So that's the main thing we're looking at is side, side, side. So we want to talk about the sides. So, oh, I should retake this. So we're just looking at this, the sides that coincide with this. So not looking at the angles. So let's see, AC, does it go with DF? It does. Though these things are true, that's not the side, side, side. Oops, take that off. AB and AC, AB, AC, hey, those are on the same triangle, so we don't want that one. AB and DE, so AB, DE, that's the upper left one, good. Mark that one, AB, DE. Then a BC and EF, so BC, EF, yep. Okay, there we go. Double checking, all right. And now here we have this proof. So we always start all of them with given. Now let's look and see what that said. AC, so AC is the same as AD. AB bisects CD. Okay, so BC would be the same thing as BD. We did that on the practice thing. That was the definition of bisect. And then AB is congruent to itself. That was the reflexive property. And now we have side, side, side. So because here's a side, there's a side, there's a side. So by side, 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 congruence, postulate, those are the same. Dun, da, da, da.